In this video, we will be discussing how to find the maximum and minimum values of functions of these forms. That is, here we have a question for sin x plus 3 cos x plus 6. Now, in these forms, we can generalize it as there will be a quotient for sin x and another quotient for cos x, and there will be a constant respectively. Sometimes there will be, the thing is, this function, I am calling this function of the form a sin x plus b cos x plus c. Sometimes the constant c can be 0, b can be 0, or a can be 0. No matter, it can be any value. Now we will be forming a general solution for this one. First of all, whatever the values you will be getting, you don't need to remember this derivation, but you need to remember the final result. Now, f of x is of the form f of x equal to a sin x plus b cos x plus c. Now I will be constructing a triangle, a right angle triangle, such that this triangle will have one of the side, you can take either base or height, whatever it is, as A, and the another side as B. Now, since this is an right angle triangle, I can calculate the value of hypotenuse as B square plus A square, or A square plus B square. In next step, what I am doing is, I will be calling this angle as alpha. You can call any angle as alpha, either this or this, no matter. Whatever the notation you will be providing here, based on that, our next step will be altered. Now, what I am doing is, f of x is the same thing. F of x, I am multiplying and dividing this f of x as root of a square plus b square on the numerator and denominator. So our function will be, f of x will become a into sin x plus b cos x plus c. Now I will be writing f of x as root of a square plus b square into a by root of a square plus b square plus b by root of a square plus b square. Also there will be sin x will be here, and similarly cos x will be here, plus a constant. Now when we observe this figure closely, we can notice that what is the value of sin alpha from this figure? From this figure, sin of alpha is equal to opposite divided by, that is this divided by hypotenuse a square plus b square. Similarly, what is the value of cos alpha from this figure? Cos alpha will be equal to adjacent this side divided by b divided by root of a square plus b square. Now we will be substituting these values. If you have provided this angle as a and this angle as b, your sin alpha and cos alpha will be different. It will be swapping. Now I will be substituting this value over here. Now our function's value f of x equal to root of a square plus b square into a by a square divided by a square. I am giving as a by root of a square plus b square. That is this value. I will be substituting this sin alpha. That value will be sin alpha into sin x plus, we can substitute b by a square plus b square as cos alpha, because b by root of a square plus b square is cos alpha. So this will become cos alpha into cos x plus our constant, plus constant. Next step, what we will be doing is, this of the form cos a cos b, cos a cos b plus sin a sin b, cos a cos b plus sin a sin b. What is cos a cos b plus sin a sin b? It is of the form cos of a plus b, sorry, cos of a minus b. Cos of a minus b equal to cos a cos b plus sin a sin b. Now this can be converted into cos of x minus alpha or alpha minus x plus a constant. Now we will be writing, as we know that sin theta, sorry, cos theta value, cos theta's value will be maximum it can attain 1, minimum it will be minus 1. Therefore, we can directly write it as cos of alpha x minus alpha's maximum value can be plus 1 and minimum value will be minus 1. Here, when we notice this one, along with this term, a square plus b square is multiplied. Now, a square plus b square is multiplied. So, throughout we will be multiplying with root of a square plus b square. Now, we will be getting minus root of a square plus b square less than or equal to root of a square plus b square cos of x minus alpha less than or equal to root of a square plus b square. Now, when you closely observe something, we have this term over here. Extra there is a constant. So we will be adding each and every term with a c. So this will be c plus, here we will be adding a constant c, and here will be c. When you add constant, root of a square plus b square cos alpha plus c. So this value is equal to our f of x. So you can replace this value as f of x. So c minus root of a square plus b square less than or equal to f of x, which is less than or equal to c plus root of a square plus b square. Or in general, our f of x is of the form a sin x plus b cos x plus c. Therefore, we will be putting this value, we will get f of x values a sin x plus b cos x plus c less than or equal to, the maximum value will be, f of x has a maximum value of c plus root of a square plus b square, and it will have a minimum value of c minus root of a square plus b square. That means we can relate with an example. For example, 5 less than or equal to x less than or equal to 10, which means x lies between 5 and 10. That means the lowest possible value of x can possess is 5 and maximum value is 10. In that sense, we can say its maximum value will be equal to c plus root of a square plus b square, and minimum value will be equal to c minus root of a square plus b square. Now, whenever you get this type of question, it is of the form a sin x plus b cos x plus c. Here a is the quotient of sin x, that is 4, b is the quotient of cos x, that is 3, and c is the this constant. So maximum value will be c plus root of a square plus b square, which is equal to 6 plus root of a square, 4 square plus 3 square, that is 9, that is 6 plus root 25, our value is 11, and minimum value will be equal to c minus root of a square plus b square, which is equal to 6 minus root of 16 plus 9, which is equal to 6 minus 5, that is our value equal to 1. That's how we will be finding the maximum and minimum value of this form of equation.